Good morning, good afternoon, good evening, depending on where you are viewing this video from. Welcome to our class for today. Today we'll continue our discussion. In this class, we are continuing our discussion on conversion of galvanometer. Recall that we have discussed conversion of galvanometer initially, and we talked about conversion of a galvanometer to an ammeter. So in our class for today, we're going to be looking at conversion of a galvanometer to a voltmeter. Okay, so please get your writing materials ready, and if you have not subscribed to our channel, please, what are you waiting for? Subscribe to our channel and give us a like, give us a thumbs up, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, invite your friends to come and enjoy this physics class that you are enjoying. This is Nobleman Science Tutors Online, and I remain your online instructor. You can reach us through the WhatsApp number that is showing on your screen. And if you have any challenge, please put it on the comment section or place it on the WhatsApp chat group. I will attend to your questions, and we are there to help you. Right, so please just get your writing materials ready, and so that we can go straight to our class for today. As I've said, we are continuing with our class on galvanometer, and today for this lecture we are looking at conversion of a galvanometer to voltmeter. Okay, so if you are ready, let us go. So a galvanometer can actually be converted to a voltmeter by connecting a high resistance multiplier in series with the galvanometer. Now take note of, remember, I said you should take note of the conversion of a galvanometer to an ammeter. In that case, you have to convert a low resistance shunt in parallel to the galvanometer. So for you to convert a galvanometer to an ammeter, you use a shunt. For you to convert a galvanometer to a voltmeter, you use a multiplier, a high resistance multiplier in series, a shunt in a low resistance shunt in parallel. Okay, so just take note of that. Shunt in parallel, multiplier in series to convert a galvanometer to a voltmeter. To convert to an ammeter, a shunt in parallel, a low resistance shunt in parallel. So please take note of these two differences. Very technical, but you can actually remember them if you understand the principle. Okay, fine. So yeah, as we stated in when we talked about conversion to an ammeter, this is current that is going into the galvanometer. This is the resistance of the multiplier that is connected in series. Then you have the PD across the multiplier and the PD across the galvanometer, then the overall POD. Is that okay? So this is basically how to convert a galvanometer to a voltmeter using a multiplier in series, a high resistance multiplier in series. So what is the formula? Let's just get some of the formulas that we need to apply. Okay, so we know that potential difference is equal to voltage times resistance. Okay, so the potential difference across the multiplier is a current and resistance, right? So the potential difference across the multiplier is equals to the current, the galvanometer current, times the resistance of the multiplier, and then the current, the PD across the galvanometer is equals to the galvanometer current times the resistance of the galvanometer. So voltmeter reading is the overall PD across the whole cell, which is the PD across the multiplier plus the PD across the galvanometer. I hope that is clear. Okay, so it is the PD across the multiplier This is your multiplier and galvanometer. So this overall PD is equals to PD across the multiplier and the PD across the galvanometer. Okay, don't forget that it is the current that is flowing through the multiplier and the galvanometer in this instance. So that gives you this V1 plus V2, because this V1 and then put it here is V2. So you have that, then this can be written as this plus this. So in this you can actually collect like terms, so that you have this will give you now your galvanometer current. So if this is your galvanometer current, you can actually have this equation so that you can now get the resistance of your multiplier. So this is your multiplier resistance, and then this is your galvanometer current. So these two equations, they are very, very key. Equation 1 and equation 3. These are the two equations that we use to solve for either the galvanometer current or the resistance of the multiplier that you connect in series with your galvanometer to convert it to a voltmeter. Okay, so let's just go straight and see how we can apply these equations that we have gotten. Question number 1. A moving coil meter with an internal resistance of 100 ohm has a full-scale deflection when a current of 10 milliamp flows through it. What value of resistance will convert it to read 10 volts at full-scale deflection? So what they're asking you to look for is the resistance of the multiplier. Okay, you are looking for the resistance of the multiplier, and we said that multiplier resistance is equals to V all over galvanometer current minus the internal resistance of the galvanometer. Now for this question, we are giving V to be 10 volts. We are giving galvanometer resistance to be 100. You are giving galvanometer current to be 10 milliamp. So divide this by 1000. It will give you 0.01 amp. Okay, so if you now substitute all this into the equation, you will have that R is equals to 10 all over galvanometer current is 0.01 minus the galvanometer resistance, which is 100. So if you do this division, you are going to have 1000 minus 100. So you can see that the resistance of the shunt is really high, 900 ohm. Very high resistance. See? So this resistance of the multiplier, is really, really high. Okay, so this setup, if you wish, you can actually draw it. You can draw it, because if you draw it, it will bring out your information very easily. So this setup you can draw just like this. This is what you can draw. The internal resistance of the galvanometer is 100 ohm. The resistance of the multiplier is what you don't know. Then the current through the galvanometer is 10 milliamp. This is the current that is flowing into the system or into the circuits. So with this, you can actually This is just a draft of what you have. Okay, it's just a draft of what you have. So with this you can solve your problems. So this is just a sketch of this question if you wish. So I just decided to sketch it so that you have a better understanding. Okay, so how that is clear, very simple and easy. So this is another sample question, and this question says that the value of the series resistance required to convert the galvanometer below into a voltmeter with a full scale deflection of 15 volt is what? It's a jam question. Okay, just so you know that if it were in jam, you don't need to waste much time. We have said that the value of the resistance equals to V all over galvanometer current, which is given to you to be that minus R, minus small r, sorry. Okay, so minus small r. So we are giving you your V is 15, your galvanometer current is 0.015 minus your galvanometer resistance, which is 5. Okay, so you can actually work this out. So if you work this out, you have 1000 minus 5. So that gives us 995 ohm as your multiplier resistance to convert it to a voltmeter that will read up to 15 volts. Okay, so the questions are basically the same. It's just for you to know what to apply to solve your problem. You know that in jam you don't need to waste time, so just go straight. So far, the important thing is that you understand what you are solving. Okay, so this is it. These are your test your understanding page. Please try and solve these problems. They are the same with what we have done already, so just solve them. If you have any challenge, put it on the comment section or on the WhatsApp group chat. I'll look to it and provide solutions. Okay. So guys, thank you so much for your time. We really appreciate you staying with us. Please subscribe to our channel if you are just visiting, and if you have not, click on the notification bell too, so that when we upload a new video, YouTube will notify you. Please also invite your friends, give us a thumbs up, give us a like. We are here to help you so that you become a better in physics. This is Normal Science Tutors Online. I remain Otobo Michael. We hope to see you in our next class. Okay, so have a nice day and enjoy your day.